Today we are going to talk about functional forms of regression models. Here we'll be discussing the log linear model, semi-log models, reciprocal models, and the logarithm reciprocal model. So let's begin with the log linear model. Now as you can see here, this model is an exponential regression model. Since you can see that here, the independent variable, that is xi, has an exponent beta 2. So it's an exponential regression model. And this model can be alternatively expressed in this way, in log form. So here, ln means natural log. So natural log yi is equal to natural log beta 1 plus beta 2 natural log xi plus ui. And if we replace this natural log beta 1 with alpha, this model will look like this. And once we replace natural log yi with yi star and natural log xi with xi star, this model is going to look like this. Now, why do we need to do this? We need to do this so that if the assumptions of the classical linear regression model are fulfilled, then by doing this, we'll be able to estimate the values of OLS estimators, that is alpha hat and beta 2 hat, using OLS method. And in this case, the OLS estimators alpha hat and beta 2 hat that we'll obtain after doing this will be blue, which means it's going to be best linear unbiased estimators of our parameters alpha and beta 2. This model is known by several other names. Log-log model, since we can see that log is on both the sides. It is also called double log or log linear model. So this model is known by several other names. One important feature of the log linear model is that here the slope coefficient, that is beta 2, measures the elasticity of y with respect to x. And since the elasticity remains same throughout, that is why this model is also known as constant elasticity model. And elasticity is nothing but the percentage change in y due to the percentage change in x, and it remains constant in log linear model. Now let's talk about semi-log models. So a semi-log model can be either log-lin model or it can be lin-log model. In semi-log models, only one variable is in logarithmic form. If the regressand is logarithmic, then we call it log-lin model. And if the regressor is logarithmic, then we call it lin-log model. So in a semi-log model, either the dependent variable or the independent variable, one variable is going to be in logarithmic form. YT here denotes the real expenditure on services at time t. That is why we have written t over here. And y naught is nothing but the initial value of the expenditure on services. So this whole thing is nothing but the formula of compound interest. Now if we represent or write this formula in log form, then it would look something like this. Now natural log yt is equal to natural log y naught plus t natural log 1 plus r. So this is how it looks. And then if we let natural log y naught equals to beta 1 and this whole term as beta 2, then we'll get natural log yt is equal to beta 1 plus beta 2 t, and if we add the disturbance term as well, then ut will also be added in it. So now if we look at this model, we can see that our dependent variable, that is yt, is in log form. But when it comes to our independent variable, that is t in this case, is not. So it is a case of log lin model. And beta 2, being the slope coefficient here, measures the relative change in y for a given absolute change in the value of the regressor. So here we are interested in finding out the percentage growth in y for an absolute change in x. So this is beta 2, which shows relative change in regressant, that was y in our case, for an absolute change in regressor, which was x. Linear trend model. Now, what we can do is, instead of regressing the log of y on time, like we did in our previous example, we could simply regress y on time. And in this case, t is known as trend variable. That is how this model has got its name, that is linear trend model. Now, if the slope coefficient, that is beta 2, is positive, it would show that there would be a positive or upward trend in y. And if the slope coefficient beta 2 is negative, there is a downward trend in y. So there are economists and researchers who prefer linear trend model over the model that we just discussed, that is log lin model, lin log model. In such a model, we are interested in finding out the absolute change in yi for a percentage change in xi. So it is just the reverse case of log lin model. In this case, the independent variable is in its log form, whereas the dependent variable is not. Reciprocal model. In this model, you can see that the independent variable has entered the model inversely, but it does not make the model non-linear. It is still linear, since beta 1 and beta 2, they are linear. So it is still a linear regression model. In this model, as the value of the independent variable keeps on increasing, we would notice that beta 2 would approach 0 and the value of yi will approach the limiting value beta 1. Logarithmic reciprocal model. Now, this is called logarithmic hyperbola or logarithmic reciprocal model. The reason being, we can see that our dependent variable is in its log form, whereas our independent variable has entered the model inversely. So this kind of a model looks quite similar to the short run production function, where we see that the production initially increases at an increasing rate, then it increases at a decreasing rate. So this model looks quite like that. It looks something like this. First of all, it's going to increase at an increasing rate and then at a decreasing rate. So till here, it is increasing at increasing rate, and after that, beyond that, we can see that it is increasing at decreasing rate. This is it for today.